Module 1, Lecture A, Introduction to the Course. Python for Chemical Engineers is designed to help you use programming as a practical engineering tool, not as an abstract coding exercise. You'll begin with the kinds of quantities that appear in everyday chemical engineering work: flow rate, temperature, pressure, units, conversions, tolerances, and safety limits, and learn how to represent them clearly, calculate with them accurately, and turn process criteria into Python logic that supports better decisions. Across 5 modules, you'll build from fundamentals to structured engineering workflows. You'll use variables, built-in functions, conditionals, and loops to perform and check calculations, organize measurements with lists, tuples, dictionaries, files, and nested data structures. Write reusable functions for calculations such as residence time, gas density, heat duty, and pipe velocity, and apply numerical methods like bisection and fixed-point iteration when equations require iterative solutions. You'll then model process streams, mixers, splitters, reactors, material balances, and energy balances with validation checks before working with CSV and text data to clean records, compute descriptive statistics, compare specifications, identify drift or outliers, and assemble a small automation project. By the end, you should be able to write Python scripts that are clear, traceable, and useful for chemical engineering calculations and process data tasks. You'll know how to structure inputs, document assumptions and units, test results against tolerances, diagnose errors, and produce outputs that support engineering interpretation. Whether you are strengthening a foundation or preparing to apply Python in technical work, you'll leave with a more confident sense of how to turn process information into reliable calculations, checks, and automated workflows. Thank you for your attention. See you all in the next lecture.